All right, so in this video, I'm going to be discussing logarithms, just kind of introducing what they are and how to write them as exponents. So a logarithm is a way to undo an exponential. And so an exponential is something where you have x in the power. And so a logarithm, eventually, once we learn through a lot of this chapter, a logarithm is going to help us solve exponential equations. It's going to help us get the exponent out of the exponent, to help us get the exponent out of the top, and so we can solve it. But a logarithm is just the inverse of putting something to a power. And so here's what a logarithm looks like. It says log, and the log is short for logarithm. There's a little number that is underneath the log at the end. It's called subscript because it's written sub means under. It's written in the bottom and it's small. It's kind of like an exponent, but it's in the bottom at the top. This is called the base. So we'd say log base 3 of 27. So that's how we would read this, log base 3 of 27. And what this means is 3 to what power would equal 27? So this is kind of asking a question. All right, 3 to what power is 27? Just like I wrote it here, 3 to what power equals 27. So based on that, we can rewrite a logarithm, this, as an exponential equation, just like this, right? 3 to what power equals 27 means the same thing. Okay, and so log 3 of 27 is just a number. It's the answer to this question down here. And so 3 to what power is 27? The answer to that is 3, right? Because 3 to the third power would equal 27. So if we were told evaluate log base 3 of 27, we were told to evaluate what this is equal to, the answer is 3. It's equal to 3 because if I do 3 to the power of 3, I get 27. All right, so that's very simple version of what logarithms are. All right, so in this case, we're going to write each logarithm in exponential form. And something that always helped me make sure I get the order correct is take your pencil, start at this little 2 here. It's called the base, and wrap around the logarithm like this. So if you draw that little wraparound arrow, it will give you the order. So we're going to do 2 to the power of 3 equals 8. So we're going to go the whole way around. So 2 to the power of 3 equals 8. Okay, and if you write, so I wrote that down, right? 2 to the power of 3 is actually 8. This is a true statement. So if you write down something that is not true, then that's probably because you wrote the order backwards or I messed up the question. All right, so 2 to the third power is 8. That is true. We can do the same kind of concept number 2 here. Take your pencil, start at 4, wrap the whole way around. That helps you figure out the order. So we get 4 to the power of 2 is equal to 16. And that is also true. 4 squared is 16. All right, and then the last one, 3 to the power of 6 is equal to 729. So 3 to the power of 6 is equal to 729. All right, keep in mind to evaluate logarithms. So if we had an example over here, log base 2 of 32, I don't know. All right, if it doesn't give me a value over here, if it doesn't say what it's equal to, and it's instead saying evaluate this, figure out what this is equal to, I can just say equal to x, okay, and then I can do the same concept I'm doing right now. So 2 to the power of x is equal to 32, and then I can solve that. So I can figure out 2 to the power of what is 32. I could use my calculator, I could guess and check, but the answer would be 5 there. So if I was told to evaluate log base 2 of 32, I would say it is 5. That's the answer. All right, so that's how you would evaluate them if you weren't given what it's equal to. If you were given nothing, you just put an x there, do the same thing we just did. So set up your exponential equation like that, and then just solve it for x. Find out what x would be. All right, so we're going to do the same thing. We're going to evaluate them now, just like we did on the last page. So 3 to what power equals 27? Remember, if there's nothing here, you can kind of assume it's x, and we're finding x. So 3 to what power is 27? And the answer to that is 3. X to the third power would equal 27. So we'd say 3. How did I know that? Well, if I was solving this exponential equation, I would try to take 27 and write it as a power, as a base of 3. And to do that, it would have to be 3 to the third power. So 3 to the third power is 27. Oh, this one's funny. 1 to what power is 1? So that means 1 to the power of what is 1? Gets crazy because anything works, literally any number. You plug a 0 in there, you plug a 10 in there, right? You plug a 12, you plug negative numbers, I think should even work. Let's check that. 1 to the power of 54, right? That should be 1. 1 to the power of negative 54 should still be 1. All right, so I could write down that x was 1. I could write down that it's 2. I could write down that it's 12, right? It's literally anything. So with that being said, you could say, why did I back this? Let's back the screen up here. You could say for this one that x is all real numbers. And I'm going to cut this short, not write the word numbers. All real numbers, any number. Log base 1 of 1 is anything. All right, and then last one, 2 to what power is 32? It's like I somehow knew I was going to do that question on the previous slide. But that means 2 to the x is 32. And your answer there would be 5 because 2 to the 5th power equals 32. All right, so there's evaluating them. And now we're going to put them backwards. We're going to go backwards. We're going to put them in the log form. And this could be a little bit more tricky than the other way around. All right, so if you remember our power here, that was our that was our answer to our log question. So that was always after the equal sign. So it was 2. And then the base a is the base of this exponent over here. So 2 would be in the base. So it's log base 2 of 4. All right. So then if you do your wraparound thing here, 2 to the 2nd power is 4. That is true. All right. So base the base goes with the base of the log. So right here. So in this case, 5 would be in that spot. So this is going to be log base 5 of, and then we use the number on the other side of the equal sign. So log base 5 of 25 is 3. So you could kind of do the wraparound thing again, I guess. You could start here at 5, and you can say 5, 125, 3. Kind of works the same way. 5, 125, 3. So we did that. We would have 4, and then the 1, and then the 0. So log base 4 of 1 is 0. All right, so anytime you have a 1 right here, right, that means something to some power is 1. And so anything to the 0 power is always 1. So that's how you rewrite it in logarithm form. I think I have one more slide here. Just solving for x. So what you're going to do is you're going to make your exponential equation. So in this case, this is the same as 2 to the 4th power is equal to x. And so all I have to do is figure out what 2 to the 4th power is, and that is 16. So my answer in this case would be 16. That one's pretty quick. This one, we have 2x to the 2nd power. When you do to the 2nd power, make sure you are doing the 2nd power for all of the 2x is equal to 36. We just have a little bit of simplifying to do. 2x squared is 4x squared. All right, divide both sides by 4. You get x squared is equal to 9, and then you can square root both sides. And so we should get that x is equal to 3, but it could be positive or negative 3, right? Square root of 9 is positive or negative 3. So either of those two solutions works. So that one's going to have two answers, 3 and negative 3. And that is all for this video.